Hello everyone and welcome back. In this video we're going to talk about a simple version of the law of total probability. Now this law says that if we are given two events A and B, then we can calculate the probability of A by separating it into two probabilities. And these are the probability of A and B plus the probability of A and B complement. So let's have a look at the Venn diagram to see how this works. So here is the probability of A, which is given by the area of this circle. We can look at finding the intersection of A and B, which is this area here. And we can also look at the intersection of A with B complement. And so this area is going to be the area inside of A, but outside of B. And so this will correspond to this crescent part of A. We will look at using this law in the next example. Now, a picture that displays conditional probabilities is called a tree diagram, and they are useful if you are only given conditional probabilities, as Venn diagrams cannot handle conditional probabilities. Now, suppose that you're traveling to Toronto from Edmonton with a connection in Calgary. The probability that the first flight leaves on time is 0.2. If the flight leaves on time, then the probability that your luggage will make the connecting flight is 0.7. But if the flight is delayed, then the probability that your luggage will make it is 0.5. So what is the probability that you arrive with your luggage in Toronto? So let's first define our events. So we're going to let capital F denote the event where the flight leaves on time. And then we'll let capital L be the event where your luggage arrives in Toronto. So let's draw a tree diagram to help us determine the probability. So first, there are two possibilities for the flight. Either the flight can leave on time or the flight is delayed. So we're going to draw two branches for each of these cases. So the flight can be on time or the flight can be delayed. And now on each of these branches, we're going to write the probabilities for these events. So we're given that the probability that the first flight leaves on time is 0.2. So we're going to write 0.2 as the probability for the top branch. And so this is the probability of F. Now, if the probability that the flight is on time is 0.2, then we can determine the probability that the flight is delayed by using the complement rule. So the probability that the flight is delayed, which can be represented as P of F complement, is going to be 1 minus the probability of F using the complement rule, which is 1 minus 0.2, which is 0.8. Then for each of these cases, there are two more possibilities. Either your luggage arrives in Toronto or your luggage doesn't arrive in Toronto. So we're going to do two more branches for each of these cases. So in one case, your luggage arrives. And in the other case, your luggage does not arrive. And now let's write the probabilities for each of these events. So we're given that if the flight leaves on time, then the probability that your luggage will make the connecting flight is 0.75. So given that the flight is on time, so we're on the top branch, then the probability that the luggage will make the flight is 0.75. And note that this is a conditional probability, so that we can write this as P of L given F, which is equal to 0.75. And again, we can use the complement rule to determine the probability that your luggage doesn't arrive given that the flight is on time. So we know that the probability that the luggage arrives given that the flight is on time is 0.75. And so by the complement rule, this tells us that the probability that the luggage doesn't arrive is 1 minus 0.75, which is 0.25. Now, if the flight is delayed, then the probability that your luggage will make the flight is going to be 0.5. And so now we're looking at the bottom branch. So if the flight is delayed, then the probability that it will arrive is 0.5. So we'll write this probability on this branch. Okay, and again, this is a conditional probability. So it can be written as the probability that your luggage arrives given that the flight is delayed. And by the complement rule, we can find the probability that your luggage doesn't arrive given that the flight is delayed, which is 1 minus 0.5, which is 0.5. So now we can use the tree diagram to determine the probabilities of all possible cases. So let's take a look at the top branch. So we have the flight is on time and your luggage arrives in Toronto. So this is the probability of F and L. And we can determine these probabilities by multiplying the probabilities along the top branches. So this would be 0.2 times 0.75, which gives us 0.15. So now let's find the probability that the flight is on time and your luggage does not arrive in Toronto. So now we're looking at multiplying the first branch, which is 0.2, times the second branch, which is 0.25. And this will give us 0.05. So now let's find the probability that your flight is delayed, which is the bottom branch, and your luggage arrives in Toronto. So here we multiply 0.8 by 0.5, which is 0.4. And lastly, let's find the probability that your flight is delayed and you don't arrive with your luggage. And this will be 0.8 times 0.5, which is 0.4. Now we can check that we made the right calculations by adding up all of these probabilities, and the total should be equal to 1. So now let's use this tree diagram to determine the probability that the luggage arrives in Toronto. So we're looking for the probability of L. Now there are two scenarios that can happen where we arrive with our luggage. Either the flight is on time and the luggage arrives, or the flight is delayed but the luggage still arrives. So in other words, we can calculate the probability that our luggage arrives by adding up the probabilities of those events. So either the flight is on time and the luggage arrives, or the flight is delayed but we still arrive with our luggage. And so really we're just using the law of total probability to find the probability that our luggage arrives in Toronto. So using what we've learned from our tree diagram, the probability that the flight is on time and our luggage arrives is 0.15, and the probability that the flight is delayed and our luggage still arrives is 0.4. And so this gives us 0.55 as the probability. Now, if your luggage does not arrive in Toronto, then what is the probability that the first flight is delayed? So here we're looking for a conditional probability. So we're given that the luggage does not arrive, and we're looking for the probability that the first flight is delayed. And so this can be written as the probability that the flight is delayed, which is F complement, given that our luggage does not arrive, which is L complement. And so to find this probability, we'll use the conditional probability formula. So this is equal to the probability that the flight is delayed and our luggage does not arrive in Toronto, divided by the probability that our luggage does not arrive. So we already calculated the probability that the flight is delayed and our luggage does not arrive to be 0.4 from using our tree diagram. And so what we need is the probability that our luggage does not arrive. So we want the probability of L complement. Well, from part A, we determined that the probability that our luggage arrives is 0.55, and so we can calculate the probability of L complement by using the complement rule. So it's 1 minus the probability of L, so that gives us 1 minus 0.55, which is 0.45. And so now we can calculate the probability that the flight is delayed given that our luggage did not arrive. So this becomes 0.4 divided by 0.45, which will be approximately 0.89. Now, are the flight leaving on time and your luggage making it to Toronto independent events? So one way that we can check for independence is by comparing the probabilities P of L and the conditional probability P of L given F. And if these probabilities are equal, then this tells us that the events are independent. And if these probabilities are not equal, then they are not independent. So from part A, we determined that the probability that our luggage arrives was 0.55. And from our Venn diagram, the probability that our luggage arrives, given that the flight is on time, is 0.75. And because they are not equal, this tells us that these events are not independent. And so the probability that your luggage arrives in Toronto will depend on whether or not your flight is on time or is delayed. Now, a common misconception about random events is that independent events are disjoint or vice versa. However, disjoint events can never be independent. If the events A and B are disjoint or mutually exclusive, meaning that they have no outcomes in common, then knowing that A has occurred tells us that B did not occur. And so the probability of B has changed from whatever it was to 0. So disjoint events cannot be independent. And as a simple example, let's consider the event A to be a 1 or a 2 on a die roll, and B will be the event of rolling a 3 or a 4. Now let's calculate the conditional probabilities of P of A given B and P of B given A. So let's define the events A and B. So A are the results 1 and 2, and B is a 3 or a 4. So the probability of B given A, if we use our conditional probability formula, is the probability of A and B divided by the probability of A. And similarly, to find the probability of A given B, we take the probability of A and B and divide it by the probability of B. So for both of these probabilities, we need to find the probability of A and B. So the intersection of A and B, we can determine the intersection by looking for the outcomes which are common in both. However, there are no outcomes in common, and so the intersection of A and B is empty. So this tells us that the probability of A and B is equal to 0. So it's impossible for the result of a die roll to be a 1 or a 2 and for it to be a 3 or a 4. And so now we can use this to determine the conditional probabilities. So this will be equal to 0 divided by the probability of A, which is 2 out of 6. And this will simplify to 0. And similarly, the probability of A given B will also be 0 divided by 2 out of 6, which will be equal to 0. So notice that the probability of B given A is not the same as the probability of B. And so this tells us that A and B are not independent events. And a similar argument is true for the probability of A given B, and this is not equal to the probability of A. So this will conclude our lesson for this video and this chapter. In the next video, we will start the next chapter on random variables and probability distributions, and I'll see you then.